So hey guys, welcome back to my channel. Hope you are doing extremely well. And this is your very own mask code on this side. And today we will be solving our 43rd problem in the series of POTDs. Today's problem is actually very hard and it's actually very conceptual. So you will have to be focused with me during the entire video. I request you to watch the video from starting till end because if you will skip it in the between, you will probably miss something very important. Okay. Today's problem name is brackets in matrix chain multiplication. Let us have a look what does the problem say. So the problem says that you have an array P of length n and it is used to denote the dimensions of a series of matrices such that dimensions of ith matrix is Pi and Pi plus 1. So there are a total of n minus 1 matrices. We have to find the most efficient way to multiply these matrices together. Okay. The problem is not actually to perform the multiplications, but merely to decide in which order to perform the multiplications, such that you need to perform minimum number. Once again, minimum number of multiplications. There are many options to multiply a chain of matrices because matrix chain multiplication is associative. That is, no matter how one parenthesizes the product, the result will be same. Please see examples for more clarifications. So, if I have been given this array as my input array, this is my P array. Okay, you can see the n here is 5, that is 5 elements are present here. So if n is 5, it implements that I have got the dimensions for 4 matrices, correct? Because it was mentioned n minus 1 matrices. Dimensions are, suppose the 4 matrices are A, B, C, and D. Dimensions are Pi and Pi, it is Pi and Pi plus 1. So it means for AH, 1 comma 1 cross 2, these two. For BH, 2 cross 3. For CH, 3 cross 4. And for DH, the last one, 4 cross 5. These are our dimensions. Okay. We have to find minimum number of operations for A, B, C, D multiplication. Okay. Now, how can we multiply? For those of you who do not know matrix chain, uh, matrix can be multiplied in any order. That is, it can be AB with CD or A with BCD or ABC with D. Now this can further be split into A into B into CD, which is or A into BC into D. Okay, and this can be split into A into BC into D or A B into C into D. So many of them are overlapping as you can already see. Okay. Now you will say the number of operations are to be equal only. No, that is not the case. Suppose we implement only for ABC. Two cases are possible. Either we multiply AB first, then with C, or with A with BC. Right? These are the only two operations for ABC. All right. So let us now continue. Let us now find out how many operations are taken for dimensions. Suppose I have a matrix A of dimensions 2 cross 3 and a matrix B of dimensions 3 cross 1. Okay. So A would look something like A, B, C, D, E, F. Okay. And B would look like something like G, H, I. You might know that the dimensions of the new matrix would be 2 into 1. That is the row number of the first matrix and the column number of second matrix. So 2 into 1 would look something like this. Correct. Now, what are the number of operations I have to continue? Now, matrix multiplication becomes something like this. This will be column number 1, this will be column number 2. For this, the value will be A into G plus B into H plus C into Y. That is AG plus BH plus CI. Okay. And for this one, it will be DG plus EH plus FI. DG plus EH plus FI. If you are finding it confusing, maybe you do not know the matrix chain or matrix multiplication rules, please familiarize yourself with them first and then you will be able to continue further. Now you can see we have to complete 1, 2, 3, 4, 5, 6 number of operations. 6 number of operation. And as you will see, the multiplication of 2 with 1 with the common factor 3 is 6. So I was trying to draw an inference that if I multiply a matrix I j with the matrix B of order j k, then the number of operations required will be I into j into k. Okay. So in the case where we are multiplying a, b, and c, in this case it will be AB, that is 1 into 2 into 2 into 3. That is 1 into 2 into 3 operations are required first. Okay. Dimensions of AB will become 1 into 3 and C is already 3 into 4. So now 1 into 3, this is for matrix multiplication, C is 3 into 4. I have to compute for that also. So it will become, so the above one is 6 plus it will become 1 into 3 into 4, that is 12, that is equals to 18. Okay. Now what about this one? So we are multiplying BC here first. So 2 into 3 into 4 will be the operations. That is 2 into 3 into 4. Dimensions of the matrix BC will be 2 into 4 and dimensions of matrix A are 1 into 2. So it will become 2 into 3 into 4 is actually 24. And 1 into 2 into 4 is 1 to 4. That is 2 into 4, 8. That is 32. Right? So as you can see, if I go by this method, that is first multiplying AB and then with C, I will get 18, which is much lesser than multiplying BC and then with A. So I will choose this method. I will provide this as my answer. Okay. So today's problem says you have to find a proper distribution, that is with brackets. Okay. So we will leave the concept of brackets for a while. We will not come to that. We will just solve how to find the minimum number, because when we will be finding the minimum number, I will tell you in between where you have to include the brackets. Okay. See how? Yeah. So you have A, B, C, D. Let us draw it downwards. So you have A, B, C, D. I say that start from this, that we have to draw all the partitions. How? This can be divided into A with B, C, D, correct? This can be divided into AB with CD, correct? This can be divided into ABC into D, correct? Only these three are partitions possible because the last one will not be a partition, it will be a whole sum. So we have to include only this one. So our array was 1, 2, 3, 4, 5. Correct? This was our input array. So if I put my I here on the first index and J here, I will have to partition. For partition, I will be using a loop. Same, the variable for loop is k. So my k will be moving from I, this is this position, up till j minus 1. Why j minus 1? Because I, as I said, I will not have to include the full partition A B C D. I have to include the maximum A B C with D. Okay, so for that one, k will move from j minus 1. The partitions here will be I to k and k plus 1 to j. These are my partitions. Okay. So I am using recursion here. As you can already see, I've drawn something like a recursion subtree here. So recursion here, how am I using recursion? F of ij is my parameters which will be varying, and for that if my I equals to j. In that case, if my I is equals to j, that is partition contains only one element, and if I only have one matrix in my current partition, then I have to perform only zero number of operations. In that case, it turns zero, correct? Okay. If that is not the case, then that is else, I will have to use a loop for number of partitions, which will move from I up till j minus 1, and steps will be f of I till k plus f of k plus 1 till j. These are the left, this is the left partition, this is the right partition, plus I will have to use a number of steps. Now, number of steps where I'm saying that if I have computed AB, if I have computed CD, I will also require number of steps to multiply AB and CD, correct? I hope you're getting my point. I have got the answer for AB, I've got the individual answer for CD, but I also have to add the number of operations required to multiply these matrices, that is AB and CD. Okay. For that, what I will do is, suppose uh, this is my A matrix, this is my B matrix, so K is actually right now here. Okay. So K is here. So dimensions of AB will be 1 into 2 and 2 into 3, that is 1 into 3. That is, if you see, dimensions of AB are actually I minus 1, P of I minus 1, P of K, correct? Dimensions of AB. What about dimensions of CD? Dimensions of CD are actually, C is actually 3 comma 4 and D is actually 4 comma 5. So dimensions are 3 into 4, that is P of K, and last dimension is P of J. So I have got my dimensions. Number of operations is easily possible now. P of I minus 1 into P of J into P of K. That is P of I minus 1 into P of K into P of J. Okay. I have to find the minimum number of steps. For that one, what I will do is I will keep a mini variable here, initializes int max in starting. Then my mini will be equals to minimum of my current mini and the number of steps returned. Okay. At last, return mini. That is the minimum number of steps required. Okay. And I think most of you know that this is a dynamic programming problem. So what I will do is I will include a programming array here. Okay. And it will be a 2D DP array because only two of my parameters are moving, that is I and J. It will be a 2D array, and I will update my dynamic programming array here. Hope you're clear with that. Okay, so let's code it down. I know most of you will be saying that we have not handled the bracket case. I will be handling the bracket case within the code itself because it is fairly easy. But if you have not understood this part, that is the algorithm to find the minimum number of operations. Please pause the video, view it again, and if you still have a doubt, connect with me on my Discord channel or engage with me in the comment section. I will surely get back to you within a limited amount of time. Also, if you have not subscribed my channel, please do subscribe it. It will bring a lot of motivation for me so that I can bring new, more amazing content to you. So let's move to the code. How will the code work? Yeah. So moving to the code, let us code down the whole code for uh, what we discussed. That is only the number of solutions, number of operations, minimum number of operations. For that, I will have to construct a vector of int, name it as dp. Okay, the size will be n, and initialize all of them by -1. Correct? Okay. Now my auto answer equals to, let me name the function as solve, and I will pass my p array to it, my n to it, and my dp to it. Now my i's are currently 1 and my j is currently n minus 1. Okay. Now let us implement the solve function. So solve is running int right now. Int solve, taking an integer array, that is my input array, the number of values present in it, and my dp array, that is vector of int and dp, current I and current j. Now my first base case was that if I is equals to j, in that case return 0. This was my base case. Okay. Now my int mini is currently initialized as int max, and I will have to now partition. So for that, int k equals to 0, k is equal to, sorry, k is going up till j minus 1 and k plus plus. So my auto left is actually now solve for left partition. It will be p n dp, and also here not really not with this, sorry for the confusion. And the partition is I to k, right? And my auto right is actually solve p n dp, and partition will become k plus 1 to j, right? My number of steps are actually left plus right plus number of operations required to multiply a, b, and c. Do you know? the individual terms. For that, what I will do is, let me correct the spelling first. Yes, steps. So it will be uh, p of I minus 1 multiplied by p of k multiplied by p of j. Right? Now, if my steps are less than many, in that case, my steps will become equals to mini, and at last return dp of ij equals to mini. Also, if my dp of ij is not equals to minus 1, in that case return dpi. That is a simple protocol for dynamic programming code. Okay. Now what I have to do, I have to implement the bracket function also here. So for that, what I will do is, uh, yeah. So instead of int, I will pass a pair of string and int. Okay, in the dp array, string and int. Okay, I will have to make some changes for that. Here also it will become pair of string with int. And instead of only minus 1, I will send an empty string with minus 1. Okay. What I'm doing is I'm counting the steps string with that only. String with my number of operations only. So it will be pair of string int instead of only int. Okay. Also in a DPR it will become pair of string int. Okay. Now if my I equal to j, then my string s is currently empty. What I will have to add is s plus equals to a plus I minus 1. What it will do is, suppose my I is on 2, okay, then I will have to add b to the current answer, correct? If I am on standing on 2 at position and I is equal to j, then I will have to add b. So what it is doing is I minus 1, that is 1, plus a. It will become b only, and it will add to the string, and I will return that string s plus s comma 0. Okay. If my dpij dot second, because I'm using a pair now, is not equals to minus 1, in that case return dpij, correct? Int min equals to int max, k equals to I, everything is running fine. Auto left, okay, okay, okay. Now steps equals to left dot second, because the number of steps are located in the second part of the pair. Okay. If steps is less than many, then I have to do, what I have to do is my string. Also, I will have to include my answer string here. String sr is currently empty. Okay. So in that case, my sr will become equals to left dot that, sorry, bracket. First at the bracket, then at the left part, left dot first plus right dot first, then close that bracket. Okay, sr equals to this, and then dpij equals to mini sr comma mini. This is my whole code, guys. I hope you work, and if you're getting worked up on this part, no need, because what I'm saying is I've just included the left and right in a bracket. This is what I have done. Okay, nothing else. Just don't complicate it in your hand. In your head, it is very easy. Just try to think. What I have done is, don't go into the deep of it, because the more you will look at the above from it, the above view, the top view, you will get a more hang of it, because you just have to see what I'm doing here. What is not, don't look at what is happening, just see what am I doing here. Hope you are liking my video. You're not getting confused. If you're getting confused and having doubt at some point, there has been an error. Yeah, it is going to be triple brackets here. Sorry for my confusion. Okay, if you're having doubts anywhere, please stop the video, rewatch it, and if your doubts still persist, please connect with me on my discord channel or my comment section. Okay. So as you can see, it is running fine for compile run. Let's try it for submit also. Hope it will work. So it is running fine. Thank you for watching my video. Hope you liked it. And please, if you are new here, please, I recommend you to subscribe my channel, because it gives me a lot of motivation. And see you tomorrow. Till then, stay safe and keep coding. Have a nice day.